Okay, we're going to do our third example of the ratio test. We've already figured out this one and this one, and now we're going to focus on this third one. So we need to calculate the limit as n goes to infinity of the absolute value of an plus 1 over an. Now our an here is minus 1 to the n times n over 5 to the n. And an plus 1 is what I get when I replace every n in that formula by an n plus 1. Now I fill in the details here. This is the limit as n goes to infinity of the absolute value of an plus 1, which is minus 1 to the n plus 1, times n plus 1 over 5 to the n plus 1, divided by an, which is minus 1 to the n times n over 5 to the n. Now I can throw away those negative ones because I'm talking about absolute values here, so their influence can be disregarded. And so this is equal to the limit as n goes to infinity. I can throw away the absolute values and the negative ones and focus on the positive part here. And this is n plus 1 over 5 to the n plus 1 divided by n over 5 to the n. And now I can invert this fraction, get the limit as n goes to infinity of n plus 1 over 5 to the n plus 1 times 5 to the n over n. Now I have some cancellation here. This 5 to the n plus 1 is 5 to the n times 5, so that's equal to the limit as n goes to infinity. I'm going to put this n plus 1 together with the n, times 5 to the n over 5 to the n times 5. That goes away, and that's 1 over 5 times. I can pull out that 1 over 5 since there are no n's in it. It's not changing as n changes, times the limit of what's left here, n plus 1 over n. And that, of course, is 1 over 5 times the limit as n goes to infinity. Dividing by n above and below, I get 1 plus 1 over n over 1. And, of course, this limit is 1, and multiplied by 1 over 5 gives me 1 over 5. So my limit is 1 over 5, and that was the limit as n goes to infinity of the absolute value of an plus 1 over an. That's less than 1, so the series, and it was that alternating series, this series converges by the ratio test.